Good morning, kiddos, and welcome to 6.4. Today we're talking about mid-segments of a triangle. So we have a bunch of review here before we move into our new stuff that we are going to use on today's homework and to solve today's problems. So the first review is how are we going to find the midpoint between 2 points? The midpoint has a formula, and that formula is m for midpoint is equal to the average or the mean of the x's. So we add our two x's, x1 and x2, and then we divide that by 2, and that will give us our new x. And then same thing with the y's. We add our y1 and our y2, and then we divide by 2, and that will give us our new y. So we're going to find the midpoint between A and B, and then we're going to plot all three of those. I'm going to pick A to be my x1 and my y1, and my B to be my x2 and my y2. It's totally fine to switch those. Those are completely arbitrary. So we have M for midpoint is equal to our x1, which is -1, plus our x2, which is -7, divided by 2, comma, our y1, which is 4, added to our y2, which is -2, also divided by 2, which will give us our new y. -1 plus -7 will give us -8, divided by 2 will give us a -4. And then 4 plus a -2 will give us a +2, divided by 2 will give us a 1. Okay, so now we're going to plot all three. Remember, to plot points, we're always going to start on the origin or the center, 0, 0 here. Then we're going to move in the x direction, positive or negative, and then move in the y direction, again, positive or negative. So we're going to let's graph A first. So that is -1, +4. So we move in the x direction, -1, and then move up 1, 2, 3, 4. Put a point there, and I'm going to label it A. And then our point B is -7, -2. So we are going to count left in the negative direction on x, 1, 2, 3, 4, 5, 6, 7, and then move down 2, 1, 2. And then plot that point B. And then this is our segment, and we calculated the midpoint for that. So let's see if our midpoint of -4, +1 is in the center of these 2 points. Okay, so again, starting at the origin, -4, so we move left, 1, 2, 3, 4, and then we move up 1. And that is on the line, that is our M, that is our midpoint, and it is equidistant from both A and B. Excuse me. Our second piece of review is how are we going to find the slope? What is our slope equation? Okay, so our slope is notated with a lowercase m for slope, and that equation is y2 minus y1 over x2 minus x1. Okay, so we know something about slope and the relationship of lines, whether they are parallel or perpendicular. If two lines are parallel, that means they are going to have the same slope. The slope is going to be identical. So example, if a slope is the same, if our first slope is 2, then a slope parallel for that would also be 2. They would be identical. They are the same. Slopes of perpendicular lines are opposite, meaning that if one's positive, the other one must be negative. And then reciprocals, which means that we are going to flip the fraction. So if our starting slope is 2, +2, our perpendicular slope is going to be negative, opposite, and then flipped. So instead of 2 over 1, it's going to be 1 over 2. So -1/2. Okay, another piece of review here. If AB is AB with endpoints of A, -4, 3, and B, 0, 2, and a segment CD with endpoints -6, 1, and D, 2, -1, with endpoints parallel, perpendicular, or neither. So we are going to figure out if the line segment between A and B is perpendicular or parallel to the line or segment CD. Okay, so let's calculate the slope of AB using our slope formula right here. So our lowercase m for slope, and then I'm going to make A my x1, y1, and my B my x2, y2. Again, this is arbitrary, so you can switch those around. So we have our x1 or x2, no, on the numerator we have our y2, which is positive 2, minus our y1, which is a positive 3, and then our x2, which is 0, minus our x1, which is a negative 4. So in our numerator or our top section here, 2 minus 3, that's going to give us a negative 1. And then here we have 0 minus a negative 4. Whenever we have minus a negative, we're not really subtracting a negative, rather we are adding a positive. So 0 plus 4 is going to give us a positive 4. So our slope of AB is negative 1/4. For CD, I am again going to make our first point C our x1, y1, and our second point our x2, y2. Again, this is arbitrary. You can switch it if you'd like. You'll get the same answer. So we have our y2, which is negative 1, minus our y1, my apologies, which is 1. Okay? And then we have our x2, which is 2, minus our x1, which is a negative 6. Negative 1 minus 1, that's going to give us a negative 2. And then again, we have minus a negative, which is really not adding a positive. So 2 plus 6 is going to give us 8. But we can reduce this fraction. We can reduce this fraction by 2. So negative 2 divided by 2 is going to give us negative 1. And 8 divided by 2 is going to give us 4. So our slope for CD is also negative 1/4. Since these slopes are identical, these two segments are parallel. Okay, now that we're done with review, we're going to dive into the new stuff here. So we are going to talk about the mid-segment of a triangle. And this is a segment that connects the two midpoints of two sides of the triangle. All right, so I'm going to draw an example here. So if we have a really basic triangle with points A, B, and C, and then the midpoint between A and C is E, the midpoint between A and B is F, and the midpoint between C and B is G. So we can create a smaller triangle within our triangle, connecting all of the mid segments. Okay? Connecting all of our midpoints, which create mid segments. Because our midpoints are E, F, and G, but our mid segments are F, G, E, F, and E, G. Okay? The triangle mid-segment theorem that says that the segment connecting two sides of a triangle is parallel to the third side and half as long as that side. Okay, so let's draw a picture and let's explain that a little further. Okay, so again, I'm going to draw the same picture as above, but I'm going to cut out some of the mid segments here. So again, we have our triangle A, B, and C. Our midpoint between A and C is going to be D, and our mid-segment between A and B is going to be E. All right, so this theorem says that the mid-segment between two sides, okay, is parallel to the third side that it does not touch. Okay, so DE is parallel to CB. Also, in addition to being parallel, DE is half the size of the base CB. Okay, so we're going to use that formula in our examples coming up here. All right, so we're going to first mess around with some midpoints here. So we have to decide where the points are for x, y, and z. So again, starting from our origin, or 0, 0 here, we're going to find our x point. So to get to x, we have to go left 1, 2, 3. So we know the x value is -3. And then to get up to our y value, we have to go up 2. So our y value is +2. To get to our y point, again, we start in the origin. This time we're moving right 1, 2, 3, 4, 5. So our x value is 5. And then to get up to our point, we move up 1. So that is a +1. And finally, to get to our point z, starting at the origin again, we're moving left 1, 2, 3. So again, this is -3. And then this time we have to count down to get to our point, -1, -2. So our y value is -2. So now we have all three of our points here, and we can find the midpoint of x, y. So again, to find our midpoint, say capital M for midpoint is equal to the average of our x's and the average of our y's. So I'm going to make x my x1, y1, and y my x2, y2. Okay, so x1, -3, plus our y1, which is 5, divided by 2. And then our y1, which is 2, plus our y2, which is 1, divided by 2. That's going to give us a point. -3 plus 5, that's going to give us 2. And 2 divided by 2 is 1. And then 2 plus 1 is 3. Divided by 2 is going to give us a decimal of 1.5. Okay, and this is again point A. It told us to name it point A. Now we're going to plot it. So starting at the origin, we're going to move right 1 because our x value is 1, and then up 1.5. Okay, so right there on that xy line. Now we're going to find the midpoint of zy. Okay, so I'll make z my x1, y1, and y my x2, y2. So again, capital M for midpoint. x1, which is -3, plus our x2, which is 5, divided by 2. And then our y1, which is -2, plus our y2, which is 1, also divided by 2. Okay, so -3 plus 5 is again 2. 2 divided by 2 is 1. And then -2 plus 1 is -1 divided by 2. If we move that to a decimal, it is -0.5, or just -1/2. Okay, so to plot this point, and this is point B, they asked us to name it in the problem. So starting at the origin, we're going to move right 1, and then down, since it's -0.5 units, or half a box here. That is point B. And then finally, we're going to find the midpoint of xz here. So I'm going to make x my x1, y1, and z my x2, y2. So again, capital M for midpoint. x1, which is -3, plus my x2, which is also -3, divided by 2. And then my y1, which is 2, plus my y2, which is -2, also divided by 2. -3 plus -3 gives us -6, divided by 2 is going to give us a -3. And then +2 plus a -2, that's going to give us 0. And half of 0, or 0 divided by 2, is still just 0. You can plug that into the calculator to prove that. It's only undefined or an error if 0 is on the bottom of the fraction, not the top. And that's our point C. So starting at the origin, we move left 1, 2, 3. And then since our y is 0, we're not moving up or down at all. So our point is going to stay on that x-axis here. Okay. So let's see. Is midsegment AB, so between A and B, is it parallel to segment XZ. That is the side that it is not touching. AB is touching XY and ZY, so the third side that it would be parallel to is XZ. So let's calculate the slope for both of these lines to see that they are in fact parallel, like the theorem says. So lowercase m for slope. Let's do AB first. So I'm going to make A my x1, y1, and then B, my x2, y2. So we have our y2, which is negative 0.5 minus 1.5 divided by our x2, which is 1, minus our x1, which is 1. So negative 0.5 minus 1.5 will give us a negative 2. And then 1 minus 1 is 0. And just like I just said, whenever 0 is on the bottom of the fraction, this is going to be undefined or an error. It's going to give you an error in the calculator. Okay, so the slope of AB is undefined. So now let's check the slope of XZ. Okay, I'm going to make X my x1, y1, and z my x2, y2. It's completely arbitrary, like I said before, just to clarify. So again, a lowercase m for slope. So we have our y2, which is negative 2, minus our y1, which is a positive 2, divided by our x2, which is negative 3, minus our x1, which is also negative 3. Okay, so negative 2 minus negative 2, that is going to give us a negative 4. And then negative 3 minus a negative 3. Remember, when we are subtracting a negative, we are really adding a positive. So negative 3 plus 3 is going to give us 0. Since 0 is on the denominator, again, this is also undefined. So even though our fractions are different, we have negative 2 over 0 and negative 4 over 0, since they're both undefined, these lines are in fact parallel. Okay? So let's do it again. Let's do CB, so this bottom section here, C to B. Okay, so CB is touching XZ and ZY, so the side that it should be parallel to is XY. So we're checking that line CB is parallel to XY. Okay, so we're going to go ahead and prove that. We have our lowercase m for slope. We're going to check CB first. So I'm going to make C my x2, y2, and my B my x1, y1. So we have our y2, which is 0, minus our y1, which is negative 0.5, over our x2, which is negative 3, minus our x1, which is 1. Okay, here we have a subtracting a negative again, so we know that that is adding a positive. So our numerator here is going to be positive 0.5, and then negative 3 minus 1 is going to give us a negative 4. If we plug this into a calculator here, we get negative 1/8. Or we could also say that 0.5 is 1/2, and we have to multiply that by negative 1/4. Okay, and that's how we get negative 1/8. And then our second line, xy here, we have our lowercase m for slope. Y2 is 1, y1 is 2, x2 is 5, and x1 is negative 3. So 1 minus 2, it's going to give us a negative 1. And then here we have minus a negative, which is really adding a positive. 5 plus 3 is going to give us 8. So again, we have negative 1/8. Since they're both negative 1/8, these two lines are in fact parallel as well. Now we have to check our third mid-segment here between C and A. CA is touching XY and XZ, so the third side would be ZY. We're going to check that those are parallel. Okay, so we are checking if CA is parallel to ZY. Okay, so again, we have our lowercase m for slope is equal to, I'm going to make A my x1, y1, and my point C my x2, y2. So this is going to look like 0, which is our y2, minus our y1, which is 1.5, minus our x2, which is negative 3, minus our x1, which is 1. So 0 minus 1.5 is going to give us negative 1.5, and negative 3 minus 1 is going to give us negative 4. If we plug that into a calculator, we get positive 3/8. We could also get that by doing negative 3/2 multiplied by negative 1/4 and get positive 3/8 as well. That negative 3/2 is the fraction version of negative 1.5 here. Okay, and then our other segment here, XY, I'm going to make Z my x2, y2, and my y, x1, y1. So my y2, which is negative 2, minus my y1, which is 1, over my x2, which is negative 3, minus my x1, which is 5. Negative 2 minus 1 is going to give me negative 3. And negative 3 minus 5 is going to give me negative 8. Whenever we have a negative over a negative here, we change both the signs to positive, so we get positive 3/8. Since they're both positive 3/8, these lines are in fact parallel. So we did prove that our mid-segments here are always parallel to the side that they don't touch, our opposite side. This is a typo here, so we are just going to ignore that. So we're going to move on to our final two examples before I send you guys off to do your homework. Okay, so remember that in addition to being parallel, our mid-segments are also half the length of our base, or that third side, that opposite side. So AB is parallel to XZ, and it is also half the length. So XZ is twice as long as AB. Okay, so going back, looking at this, if KM, this third side, is 15 units long, then what does the segment that is half the length have to be? So what we'll do is we'll just take 15 and divide it by 2, which is going to give us 7.5. Okay, but if HI, the smaller segment, is 22, what does the larger segment that's twice its size have to be? We will just take 22 and multiply it by 2 and get 44.